Okay, so hi, I'm Simon. We're under strict orders here to start on time, so let's get going. This is a talk about how we built a mobile social network for people living in the townships in South Africa. And what I'll talk to you about is some of the history of the project, and then we'll dive into some of the technology and the protocol stuff, and then we'll look at like how do we deploy the software. So it was about a year ago I got a call from this guy. This is Alan, not Craig, and he lives in a castle in South Africa, and they do Wi-Fi. So basically, if you live in South Africa, your phone usually never works because people drive around and they pull the copper out of the ground and then they go and sell the copper. So you either get a fiber optic circuit or you live on Wi-Fi. And so he runs a project that gives out Wi-Fi to people. And he came to me and said, you know, we've got all these people using Wi-Fi. How can we build a mobile app to connect them? So what we do is we build an open source in-app messaging stack. So that means if you want to, if you've got a little mobile app and you want to add, like get your users talking to each other or talking in a group or doing social Facebook feed type things, you drop our open source stack into your app and it magically enables this conversation. So it basically gets your users talking and sort of increases the interactivity. We really like doing this. We've done this for a long time. And we do everything as an open source thing. We've got a big open source thing, team, and we produce all sorts of different components that you would probably need to do messaging in an app. And we'll cover what these different components are a little bit later in the talk. But the end result is that you can add communication to your app. And of course, it's Apache 2 licensed, which means you can do whatever you want with it. But before we talk about that, I sort of have this theory that there's this new world order here, where it used to be that if you built an app, it would sort of expand and do more things until it read your email. And now it's like every app expands until it has a chat layer in it. So if you look at something like Airbnb, you're now chatting with your guests. If you look at so many apps, there's always this sort of chat layer inside of an app. There's even a project that we worked on where if you're on a building site, you would then communicate, like the plumbers would be communicating with the electricians to make sure that different things didn't cross. So it's sort of like chat is everywhere. And in this talk, I'm going to talk, you know, we produce an open source project, and we're quite keen on the open source side of things and using open protocols, not trying to invent something proprietary. But at the same time, there's this need to be pragmatic and need to get something out there. So we try to be more on the pragmatic end, but still give you the tools that you need to build what you need to build. So with that in mind, when we started this project, we were looking around for like what protocol should we use. And we started this actually back in, gosh, like 2008, 2009. These are the sort of dark days of Nokia handsets where you didn't have push notifications. You had to build an app and then you would send it off to Nokia and you'd wait like 30 days for them to sign it. Then you'd find out that there's something wrong. You have to pay another $100 for another signing. So it was a dark time. But one thing that we really liked was XMPP. XMPP is in a lot of different places. So it's probably powering your WhatsApp conversations right now. It's powering your Apple push notifications. It's a messaging protocol. And it's a little bit different to the sort of web model where everything's, you know, a get and a put, whereas this is more of a stream-based protocol. So you open a connection and then just firing messages through it and getting messages back. And because of that, it's used in quite a lot of places. Obviously, it's used for chat a lot, but it is used for push notifications, for example. And we chose XMPP because we sort of have this theory that instead of trying to build something new, and trying to reinvent something, usually an open protocol will win out. We see some pushback on the XMPP side, but generally an open protocol sort of pushes out, wins out against some of these things. And I think, some of these protocols, like the blockchain, for example, they have potential to win out, and we think XMPP is heading that way as well. So this is the quick XMPP 101. XMPP addresses look just like an email address, and if you think about email, you send an email to your email server, and then it sends it to the remote email server. And XMPP is very similar to that. When Romeo wants to send a message to Juliet, he talks to the Montague XMPP server that connects to the Capulet XMPP server, which then connects out to Juliet. Except unlike email, where it's sort of store and forward, what's really happening here is that you're just creating a connection from one server all the way through to the next server. So this connection just stays open and messages are flying backwards and forwards then. And the other thing you'll probably notice is that this is a distributed system. So unlike some of the current implementations, like for example Layer, where everything's in the cloud and you push all your messages just up to one provider, or the fact that you have, if you look at your phone, you don't have an email app for your friends on Hotmail and another email app for your friends on Gmail. You just have one email app and it connects to friends on all the different networks. So XMPP is very similar to that. You just have one app and it connects to users wherever the server is. Now I know some of you are probably drawing in your breath because you're seeing XML, but the messages are based on XML, and it means that they're quite extensible. So instead of, you have your basic message, but you could then add in extra things like this threading and add extra attributes depending on what your chat application is. And as I mentioned, it's federated, so your one server can then connect to all the different servers in the XMPP network. So then the final part about XMPP is that because it's really a server, it's really like your email server, you can run it inside your organization. So this is one of the sort of selling points that we've seen when we've been talking to companies about this, is that particularly if you're in healthcare or finance or government, in fact one of the groups that we work quite closely is with the government, and the government doesn't just put all their data into Amazon's cloud services, they actually have to run it on premises for privacy reasons. So XMPP means that you can run your server behind your firewall and keep your data secure that way. Anyway, the final part about XMPP that's super nice is that it's really like, if you think about your web app, you have maybe your Nginx layer, and then you have your application server sitting behind there. So this gives you something very similar in that you can have for example, a media server, or in our case, we wanted to do location sharing. So we just built a little process. We stuck that behind the XMPP server, and then we were able to do real-time messaging to that process. It gives you that component model. So earlier I showed you a message of how people were chatting, but it's also possible to then send data backwards and forwards, in this case, sharing location you'll see that there's a service that's running on Shakespeare.lit, and it's just called location service. So it's a nice way to send messages backwards and forwards. And then when we put this all together, we basically have a system that looks a little bit like this, and I'll just step you through some of the components. But you have your XMPP server here. So this is like talking to all of the other XMPP servers in the world. It knows how to look up and find, if somebody's using example.com, it knows how to look up the XMPP server for example.com in the same way that your mail server looks up the mail server for example.com. And then it'll connect out to other XMPP servers. And then what we did was we said, if we're building a messaging system, we don't want to be building some sort of monolithic service. I know the phrase now is microservices, but when we started working on this, there was no microservice. But we sort of thought, the Unix model is really nice. The Unix model of building small discrete services that you can then chain together that just do one thing and do it really well is a nice way to build like messaging services. So for example, if you just want to chat, you just build a chat service. If you want to share media, you have a media service. For push notifications, there's one service just to do that. So that's really how we've tried to do it. And each of these is then a discrete project on GitHub that you can sort of plug in. So when you're building your messaging app, you just grab one of those, plug it into your XMPP server, and you're away. And this is quite nice because some people really just want to do user-to-user chat, so they've only got one thing to install. They don't have to go through a whole lot of stuff. So before we go on to the project we built in South Africa, I'll just quickly talk you through how do you, I showed you earlier the messages going backwards and forwards, the location service message. So we started out this project, and first we were just doing chat messages, and then we realized, okay, we want to share location, but how do we make this into really a standard that other people can use? So we had our location thing, our location stanza. What we were doing is grabbing location from different cell towers, or looking for cell towers in the area and then sending them back to our location server. And then we wanted our location server to say, we think you're in this rough area. And we thought, this is kind of useful. Maybe we should publish this as a standard that other people can use. So we wrote it up. And then the process is that you jump on the XMPP standards mailing list and you talk a lot. People will pick apart your specifications, say, have you thought about this? Have you thought about that? And then you end up going to the XMPP Summit and you hack on all sorts of stuff and you talk more about the standard. And finally, you actually get a standard and it's published, and then people start using it. And if enough people use it, then it changes from a draft standard into a real standard. So yeah, that's XMPP. That's the basic sort of messaging layer that we've been building on. But what I wanted to talk about is that if you're going to do any type of messaging, you're going to need to do push notifications. As I mentioned earlier, when we started out with this, we started out on Nokia phones. This is back when you had to build with Symbian C++ stuff, and it was really horrible. The biggest problem was that we were building a mobile social network, and a social network's not much fun if your battery's dead by midday. So we had to really optimize all sorts of stuff on the phone to keep a TCP session open to the phone all day, so that if you got a chat message or if you got a little update, we could then open up the app and do stuff. And that was back in the day when you only had 3 or 4 apps on your phone, and most of them didn't run all day long. Nowadays, you've probably got 100 apps on your phone, and they all want to be getting stuff. And that's where the push notifications come in. So if you've got a web browser and you've got your phone, ideally you're just sending messages backwards and forwards, and that's super easy. And you probably, if you're building a service, you want a backend so that when your web app's not on, or when your user on the web app or your user on the mobile phone is not on at the same time, your messages are then spooled up on your backend, and the users can get them. But thankfully, Google and Apple came along with push notifications. So you could basically have your push notification service sitting in the cloud, and instead of having every application having its own TCP session open all the time, doing keep alives, dealing with horrible NAT gateways on the carrier networks, Google and Apple basically made the promise, well, we're just going to keep one TCP session open to our push notification gateway, and then we'll give you a nice API to just push data through this. So that's really the promise of push push notifications. Your application backend can just send something to Apple or Google, and then they'll bounce it out to your phone. And this is all very good. In the case of our little Nokia app back in the day, it meant that we didn't have to care so much about battery life. And it's mostly quite an easy to understand pattern. There are some problems though. You can only push certain amounts of data, and so that's really where this push-to-pull model comes in. So this is like a pattern that if you are building a mobile app now, I guess it's the de facto way of doing it, where you're saying, here's a push notification. I'm not going to include all the data in the push notification, but when you get this push notification, wake up the application and then pull in the data from your REST API. And the conversation goes something like this. You know, there's some fresh content, somebody liked you, somebody updated something, connect to the REST API and get all the data. And your phone goes and does its thing. So this is quite a standard model. In our case, we have the channel server. So this is the part that's doing all of the social activity feed. That's like the, somebody liked you, somebody updated this. And the moment we see any activity on that, we're just immediately mirroring all data over to the push notification service. So this means that you can then define filters. So maybe you don't want to push notification for every single like, or maybe you don't want to push notification for every single message. But because you're just mirroring all messages across to the push notification service, you can then work out what kind of messages do we want to filter for. And then, of course, it goes out to Apple or Google's push notification service. And your app wakes up. But with push notifications, we start running into all sorts of horrible things. So I feel something buzzing in my pocket, and I pull out my phone, and I turn it on, and I want data there. And we've sort of been calling this the time to glass problem. You want to turn on your phone, and you want something immediate satisfaction. You don't want to wait for all sorts of background resynchronization. So yeah, we've got this. This is sort of the common thing that happens. Your phone is getting data, but then it's got to do another round trip, because here we have the author ID sending something, but you don't actually know who the author ID is. So in that case, you've got to like go and look it up again. So not much we can do about the speed of light and the latency for getting this stuff, but we can, on the back end, fix some of this stuff where we can, instead of, let me just go back to that, sorry. Yeah, so we can actually include names. So you're really trying to limit the number of round trips that your application's having to do to be able to paint a screen. And this is important, really, because of this speed of light problem. You know, when your phone comes online and needs to start doing stuff, you really have a lot of round trips that need to happen. So you've got to build a TCP session. You're probably going to want to layer some TLS on top of that for security. And these things start adding up rather quickly. So yeah, by the time your phone is actually getting data, you're looking at 2 or 3 seconds. Sorry, let me just jump through that. Yeah, there's basically a lot of handshaking going on. You've got your 3-way handshake for TCP, and a while to actually get all the security, all the TLS stuff set up. So yeah, this is sort of one of the barriers that you're not going to be able to get around. And so what a good way to think about handling this is that when your phone is getting the push notification, automatically in the background it's starting to synchronize stuff in. And that way, by the time you've pulled it out of your pocket, it's actually synchronized enough data to be able to paint the screen. The alternative approach, which I think is cheating a little bit because it uses a lot of more bandwidth, is something that, for example, Instagram does, where they just randomly every 10 minutes or 20 minutes going out and pulling in new data rather than waiting for all the pictures to synchronize when you pull out your phone and look at Instagram. Yeah, so this is a quick summary for reducing this time to glass. We found that really it makes a lot of sense if you can try and get the screen painted within 1 second of the user pulling out their phone, then we sort of have the very happy eyeballs feeling that the user's getting their content, they're getting their fix. Perhaps the biggest thing that's going to really help will be HTTP 2.0, because then you've just got one session going back to the server, pulling in your images, pulling in your API stuff, and you're not having to spin up multiple different connections, one to your image CDN, one to your API. And then the other problem, or the other super suggestion, is that there's a lot of broken TLS setups out there. So if you use Nginx or Apache, there's some really good example configurations for how to set up your web server to send down all the certificates and everything that the client needs to be able to do a one-shot TLS setup. So yeah, we've got all the building blocks now. Remember that at the start of the talk I showed you Alan, not Craig, saying, hey, we want to build this mobile app. And we've only got 10 days to build it. Like, what can you guys do? So if you think about what we needed to do, we needed to discover our API. So we had no app at this point. We're sitting on the ground in South Africa. We needed to get users signed up. We needed to get them onboarded. We needed to get them doing discovering content early on so that they're using the app, and then actually interacting with the app and starting to be productive. So it's quite a tall order to build this in just 10 days, but we sort of felt like we had all the building blocks. Now we're just going to really jam and throw it all together. So the first part was a little bit of an abstraction. We like our abstractions, as you can tell. We needed to look up the API. We wanted to have a system so that anybody, like with XMPP, anybody can run their own server. So it's sort of like right now when you use the Facebook app, you always connect back to the Facebook API. In our case, we wanted to say, maybe somebody else wants to run their own version of the software. How would you tell this one app that you've downloaded from the App Store that if you're a user on this domain, you connect to this API, or if you're a user on this domain, you connect to this API? And the way we solved this was in DNS. Before you start doing anything, you do a little DNS lookup, and you're basically asking for the service record for the API. And that's just returning back the host name, whether you should use HTTPS, the path that the API is rooted at, and of course the port. And then you connect to the API and start doing stuff. So can anybody see the problem with this? We've got a mobile app that's expecting to do REST stuff, and we've got a messaging protocol that's sort of session-based and has absolutely nothing to do with REST calls. It's something that supposedly sets up and is just sending messages through. So this was a little bit of a problem, and we solved it by basically building an API. And our API would say, here's a REST call, we're going to spin up an XMPP session on the API, and then do XMPP calls below. And that meant that we could then do we could have like the best of the REST world and the best of real-time messaging. But the other problem was that because these guys that we're working with in South Africa, they're an ISP, they already have a user database, expecting users to register was a no-go. So we had to look at like how do we do external auth. And that was basically they have their LDAP database with all their users in, and we had to build a plug so that basically we're saying this is a username, this is a password, true or false, and that would then authenticate you on the system. Then we had the onboarding problem. Coming back to the Instagram example, I don't know if anybody's noticed, but they do such a fantastic job of, or even better, Telegram. Telegram's onboarding was just fantastic. It grabs your address book. It then notifies your friends that you've just joined Telegram, and you sign up and suddenly you've got 3 or 4 messages like, hey, welcome to Telegram from friends. And you feel like you're immediately productive. And I think this is the real trick to building good apps, where you've got this onboarding process down. You want the user to feel plugged into their existing friends. So our way of solving this was we had 2 components. First, it would auto-subscribe you to popular channels. And then secondly, we would try to show you active content. So we had a little crawler, and that would go through and show you, like, you know, in the last hour, a lot of posts have gone to this channel. So for example, the free Wi-Fi channel was always very popular. But we also built something else which was kind of cool. You know, when you're browsing Amazon, Amazon has this book or recommendation service. Like if you looked at this, perhaps you like this. We did the same sort of thing where we could say, you know, these users follow this channel, therefore you can, if they follow this channel, then perhaps they're interested in this. And that really helped a lot. And we would show users this little screen of active users, popular users, and then recommended users. So here's an example. And there's two ways of doing this. It's like based on what you follow, you're interested in this, or channels that are similar to this. And one thing that we're still working on is this nearby channels. That's basically saying, you know, if you're at a conference or something like that, you can pull out your phone and you can just find like activity feeds from the area because they have geo coordinates attached to them. And then the next part we had to solve was obviously posting. That's relatively easy. We used a threaded model. So instead of something like Reddit, where you've got threads going down like 10 or 11 levels deep, we said, look, this is a mobile-first application. We're just going to have a topic and comments, a little bit like what you have on Facebook. Although I believe Facebook is now sort of, you can go 3 levels deep. But we found that this worked quite well because it would try to keep the conversations a little bit more on topic and be a little bit more accessible on a mobile screen. But because this is the internet, you have to share media, and it's very, very important. So we, as I showed earlier, there's the media server. And this has actually turned out to be one of the most successful parts of the project. Not cat pictures, unfortunately. We had a little bit of a problem with some of the content that was shared. But media really drives this. And we found that super exciting just to see like how people were using it. We even had one user, she would record just random sounds around where she lived and post those. So yeah, as I mentioned earlier, we've got this clash of the XML versus the JSON, or the REST API versus the XMPP land. And that's really just a diagram to show you how we sort of split it up. So here we have our mobile app, and it's always connecting back to the REST API, which then handles all the XMPP stuff below. But for REST is really great for mobile stuff, but JavaScript and WebSockets start to give us a service that's very similar to XMPP, in that it's a sort of real-time messages just flying backwards and forwards over one connection. So one of the Buddy Cloud developers developed XMPP for the web, and this is a really, really nice JavaScript library that basically gives you all of the methods from the server and just presents them as a simple to use JavaScript library. And I'll show you some examples of that now. So jumping forward, the project's all open source. It's on GitHub. Pull requests are very welcomed. And it was a super interesting project because if you think about these people, they have their mobile phone is their home computer, is their laptop. And we started the project thinking, okay, we're going to have to build super low-end phones for super low-end phones. But it turns out when your phone is also your home computer is also everything, you tend to spend a bit more. So the phones weren't as bad. I mean, I think we've all worked on projects where we've had to support IE6, and it wasn't quite as bad as that. The bigger challenge was the fact that the power kept going out. So we were sitting on the ground in South Africa, and they have this thing called loadshedding, which basically means they haven't built enough power stations, and power gets shut out different times. So you quickly learn who has the newer MacBook and whose battery is a little bit older by who stops working first. But yeah, so this is the first example of XMPP for the web. So this is from the project, and this is basically just logging in. You'll notice here that we're really just sending your ID, because it's XMPP, it's called a Jabber ID, and a password. And all we're doing is creating a connection. This will simply authenticate you. However, if you actually want to start getting data, all we've got is this connection. To start getting data, you're going to say, you're going to send presents. And that's basically saying, I'm online, my application is running, you can start sending me real-time data as it happens. So if I get a chat message, now I'm in a state where I can start receiving it. So when you send presents to the service, you'll start getting all of your updates from the last time that you were online. So somebody liked you, somebody did this. Any new updates will then come through straight away. Yeah, so I mentioned the channels earlier. These are some of the channels that we auto-subscribed users to. There's and we just found that this helped people with the onboarding process to have a little bit of content that they could start accessing. But because it's the internet, it's really nice to have user-generated content. And so there's a way to create a channel. I should add that channels are just publish-subscribe nodes. Probably the same in the same way that posting to Twitter is it's almost like a publish-subscribe model. You've got somebody who can publish to your Twitter feed, and then a whole load of subscribers. This is very much the same. But just like when you create your Twitter account, you set your Twitter feed to be open or closed, and we're doing that here, if people can follow it or if they need to be authorized to follow it. And then, unlike Twitter, where you're the only publisher who can publish to your feed, what we said is that it's nice to have multiple people. So in like a chat room, basically everybody's a publisher. They can publish chats into the room and other people subscribe to it. So we have this model where when you follow something, you can be a publisher or you can just follow it. And so when Lady Gaga finally joins, obviously we don't want everybody following Lady Gaga to be able to also post into her channel. And then that would just be a follower value. So yeah, that's an example from the code of just creating one of these channels. And then, of course, you're going to want to push messages in. And here you can see the threading. Basically, it's topics and then comments, which worked out quite well. What are we doing here? Yeah, so imagine you haven't been online for a few days. So you come back and you've got this mobile web app and you pull it out and it starts synchronizing over a slow connection. And maybe there's 1,000 messages to pull down. The last thing you want is the user to then get frustrated and quit the app while it's sort of half pulled down messages, or to not see any feedback. So we sort of solved this using this feature called result set management. Where do we see that? Yeah, result set management, where we said, instead of saying, give me everything since the last time I was online, we said, just give me enough to paint a screen. Give me like the last 6 messages in this case. And that was a big win for us. Yeah, so finally we've got just basically publishing to a message. So it's very, very standard JavaScript. And with that, I'll wrap up and take any questions. But if you wanted to add BuddyCloud to your app, we've got a few little recipes there for how to do it. Everything's open source and everything's on GitHub. And be very happy to help anybody who wants to do open source messaging. Any questions? Okay, I've thoroughly confused everybody today. Yeah, one in the back.
I just have a question. I didn't use MQTT binary protocol in the sense a lot less data.
So, yeah, this argument always comes up. It's a little bit about the infrastructure. So MQTT will certainly be a nice binary transport, but there's also when you run XMPP through a zlib compressor, you're probably down to about 10% of the original size. So it's very quickly basically an infrastructure trade-off. Like with XMPP, we're sort of getting a big jump up because we're not writing a complete message routing server on the bottom. Yeah?
I'm a bit confused. Are you offering this BuddyCloud service as an open source in a way that everybody can use it and set it up themselves, or are you
exactly
selling it as a service?
No, we offer it as an open source package. It's completely federated, so if you run one and I run one, my users can talk to your users. We've also helped some companies set it up. We find that the companies that are most interested in it are the ones that are a little bit more concerned about security. So healthcare, government, finance, pharma, because it can be run on premises. No? Anything else? As we wrap up. Great, thanks everyone.